So it says, given that f and g are inverses, and you're like, I can't remember much about it. Don't worry, I'll give you a reminder. If the point AB is on the graph of f, then do you guys remember functions are inverses? The points just get flipped. So if AB is on f, then look what we do to that point. It's just BA is then on G. So the points always get flipped when they're inverses. So it said, hey, here's a table for f. What would then be a table for G? So if I say, hey, we got the point -3, -26 on f, what would G's point be? You got it. He says, oh, just flip it. And then -2, -7 turns into -7, -2. -1, 0 is going to be 0, -1, etc. Then what if I said, hey, estimate the slope when x is 1? We've done this before. How do we find the slope there? Estimate that slope when x is 1. Yeah. Oh, sorry. When x is 1, that doesn't go between 2 and 3. What a dope. When x is 1, you said, okay, I'm going to use those points on either side. And you're saying 9 minus 1 over 2 minus 0. What are we saying that slope would be?
4.
9 minus 1 is 8. Divided by 2 is 4. Anyone have any idea what? Well, let's just do it. What the slope when x is 5 is going to be?
1/4.
How'd you think of that?
Because 1 over, because it's in the
Yeah, but how did you know it was going to be 1 over? You're exactly right. What made you think that?
It's just the only thing that makes sense.
Okay. Yeah, Mr. Blake?
Like the inverse of it.
Say it again.
The inverse of it.
The inverse, exactly, the multiplicative inverse, well said. So when x is 5 here, if we did change in y over change in x, we get 2 over 8, which is 1/4. And that's exactly right. Inverses, multiplicative inverses, when you multiply these together, we'd get 1. All right, I like where our heads are. So inverse function slopes are, what word do you think would go here? 4 and 1/4 are what of each other? Well, multiplicative inverses, I agree. They're really, if we just flip something, it's the reciprocal every single time. Inverse functions, slopes, are reciprocals. So then I said, okay, so if functions are inverses, when you compose them together, you get x. Which I don't think is a big deal. It's what I just skipped. If I plug g into f, then I'm going to get x. If I plug f into g, I'm going to get x. I'm not worried about it. Let's go do this on this graph. So I said analyze y equals x cubed on a table and graph it. We just need to graph that. So let's go pick some x values. If x was 0, what's 0 cubed?
0.
0. What if x is 1? 1 cubed? 1. If x is 2? 2 cubed is 8. What if we go -1? -1 cubed would be -1. -2 cubed? -8. Let's go plot those 5 points. I got 0, 0, 1, 1, 2, 8, 2, 4, 6, 8. And then I'm going to go -1, -1, -2, -8. Excuse me. And I'm going to go attach all those with a nice x cubed graph. We know that that's what x cubed looks like. You guys, if this had these 5 points, can we write what its inverses points would be? What would 0, 0 turn into for an inverse?
0, 0.
0, 0. Flip those x's and the y's. I'm going to do this one in blue. What about 1, 1? 2, 8 would turn into
8, 2.
8, 2. -1, -1? -1, -1. -2, -8? -8, -2. Let's go plot those points. A lot of them seem similar. That's fine. We still have 0, 0. We still have 1, 1. And we still have -1, -1. Those 3 points still match. But then I've got 8, 2, and -8, -2. 2, 4, 6. I didn't do that at the right spot. And then we also have 2, 4, 6, 8. Boom. This is its inverse. So here's what we got to take from this. This is what AP is going to ask. It says, hey, what's the slope of x cubed? And we already know this, you guys. What's the slope of, y equals x cubed? Let's go do that with our derivative. What would the slope of x cubed be? dy dx would be 3x squared. And I then said, okay, well, does anyone remember if y equals x cubed is the first function, the inverse of x cubed, if this is x cubed, does anyone remember what this graph is?
It'd be x to the 1/3.
Yes, how'd you remember that?
Okay. As a reciprocal is that value to the negative first.
Nice. Yeah. Okay. So the inverse is y equals x to the 1/3. Again, you wouldn't have had to pull that. Let's go find its derivative. What would the derivative of this one be? 1/3 x to the negative 2/3, which is the same as 1/3 x to the 2/3. Now, let's go find the derivative. Let's go back to this one of my original function. And I'm curious, what's the derivative when x was 2? Let's go find this derivative when x was 2 of my original function. Do I do 3 times 2 first or 2 squared first? 2 squared, so my derivative when x is 2 would be 12. When x is 2, what point did our function have when x was 2? Do you agree we had the point 2, 8? So I'm going to say my slope was 12 at the point 2, 8. So now I want us to think, what is the slope over here at its inverse point, 8, 2? Anyone have it's going to be 1/12. Let's go prove it real fast. At the point 8, 2, I only have to plug in 8 for my x because there is no y over here. So I'm going to go plug in 8 for my x, and I want us to practice. How would we do 8 to the 2/3? That's power over root, but never do the power first. It sounds miserable. Do the root first. What's the cube root of 8? And I'm going to write that out. 1/3 times 8 to the 2/3. Cube root of 8. 2 to the second power. 4 times 3, 12, and we get 1/12. What this is asking here is if that was my function, what's the inverse's derivative when x is 8? That's what we just found. And so I'm just going to even draw an arrow right there. This is asking for the inverse. F to the negative 1 is inverse. The little apostrophe is asking for the derivative when x was 8. Here's more like how AP is going to ask it. It says, hey, let f be a function such that this info is given. All right, how I like to write this is let's go make 2 different tables, one for f and one for g. They're saying the f function has the point 520 and also has the points 7, 5. And maybe I'll even put those as like x's and y's. You don't have to make it that thorough if you don't want. We have the point 520 and 7, 5, right? I'm not even going to go any further. I've only looked at this piece of information, and I want you to then go make a G table. What would G's table have as its points? If the F had the point 520, what does G have the point? 20, comma 5, bless you. If F has the point 75, G has the point 57. Very good. So it says, then they also told us F prime of 5 is negative 4. F prime of 5, if I wanted to put that, I guess I should have separated these out. I'm going to put it down here. I'm going to say F prime of 5 is 7, 4, negative 4, negative 4, negative 4. And F prime of 7 was negative 5 halves. They're letting us know F and G, this right here is saying G is the inverse of F. So if you need to remind yourself of some lingo, that's saying G is the inverse of F. And they want to know what is G prime of 5. They want to know g prime of 5. So, you guys, if we've got the point, they want to know the slope when x is 5 here. They want to know the slope when x is 5 here. So, do you think we should look at the function when x is 5 or the function when the y is 5?
The y is 5.
When the y is 5. So this is tricky. Let's think about this. My functions have inverse points, right? So if they want to know what g prime of 5 is, I've got to go find f prime of 7. Did they give that to us? They gave that to us right here. They gave that to us right here. And whatever that slope was, which was negative 5 halves, this slope is going to be the reciprocal. So what do you think we'd say g prime at 5 is? Negative 2/5. Done. What trick they want us to fall into is they want us to go say, oh, well, f prime of 5, because they gave it to us, was negative 4, so the inverse will be negative 1/4. And we're not going to do that. We need to go to its inverse point, find its slope, and then flip it. Okay, so on this guy, they didn't give us points. They gave us actual functions. It says h is this function, and then they gave us a point. H of 1 is 2. They want to know what is the inverse's derivative when x is 2. So here's how I like to think of it. All right, if we've got h has the point 1, 2, what would its inverse have the points? What points would the inverse have?
2, 1.
2, 1. So at these points, you guys, their slopes will be reciprocals at these 2 points. So can we go find h prime when x is 1? Because then its inverse's slope will be the same when my x is 2. So let's go find h prime of x. What's h prime of x? Here's h of x. What would h prime be? Love it. 5x to the 4th plus 3. Beck, when x is 1, I want to go find h prime of 1 now. If x is 1, guys, what would be my slope? Yeah, 5 times 1 to the 4th would just be 5 plus 3 is 8. If h prime of 1 is 8, then I know its inverse, how I'd write that, is my inverse. H to the negative 1 is inverse. And then I'd say that guy's derivative. So many superscripts here, right, you guys? Superscript of negative 1, this means derivative. When x is 2 is going to be how much? 1/8. You got it. So this is us recognizing if they give us a point, we got to flip it. Whatever my slope was over here, my inverse slope will be 1/8. Notice that my x values are different, though. This is my slope when x is 1. This is my slope when my x was 2, because they're inverse points. All right, let's try that again. Here we go. F and g are inverses. My function has the point. If my function has the point, negative 5, 7. What points does my g have?
7 negative.
Yes, sir. I think it's just good to visualize that. Then they said, oh, g prime of 7 is 3. This is all information that they gave us. Well, they gave us that. We then took it and ran with it there. Then they gave us this. Then, you guys, they want to know what would f prime of negative 5 be? 1/3. You got it. We just take this and we take its reciprocal. An increasing function satisfies this information. It's saying my f function has the point 10, 5. And then it's saying the derivative at 10 is 8. This is just saying, do we know what these symbols mean? What I like to do at this point is they're saying, hey, what about its inverse? F to the negative 1 means inverse. So I'm going to go right. All right, the inverse would have what points, you guys? 5, 10. What would the inverse's slope be? How would we write that? We're going to say inverse, so that's f to the negative 1. Its slope at what x value would be what? When x is 5,
It'd be 1/10.
it would be 1/8.
8.
Very good, Q. So many. Boop. Is that an answer? I don't like 8, I don't like 10, I don't like 10, I like 1/8, and do we agree with that formatting? Yeah, my inverse, this is derivative, when x is 5, is 1/8.